Honors Algebra 2, Chapter 8, Section 1. We'll look at variation and the different types of variation. So there's three main types of variation. We're talking about direct variation, which two values vary directly. You get y equals a times x, where x and y vary directly. Inverse variation, y varies inversely to x, so y equals a divided by x. And then joint variation, which is a new one for you, is z equals a times xy. So z is varying to two different quantities. So this occurs when a quantity varies directly with the product of two or more quantities. So a here is called the constant of variation. So for all three of these, a, the constant of variation, is a value we need to find usually, or it may be given to us. That's a value, that's a constant value of how the variables x and y vary, and it shows the relationship. So a few examples here. Let's tell whether the x and y show direct variation, inverse variation, or neither. So when you're given an equation, sometimes you manipulate it so y is by itself, so we can divide both sides by x here. So the rewritten equation could be y equals 7 divided by x. Then I can see the kind of variation it is, and so this would be an inverse variation. So here if I get y by itself, it already is y equals, so I don't need to change the form of it. But for that one, it's neither. It's not direct or inverse variation. The last one, I can multiply both sides by 4, so I get y equals 4x, and then that one would be a direct variation. So knowing when y equals, what kind of variation you're talking about. So example 2 here, the variables x and y vary inversely, so it tells me the form I'm dealing with, and y equals 7 and x equals 4. So since we know it varies inversely, right away I can set the general form y equals a over x. That's the form for inverse variation. So then I'm told that y equals 7 and x equals 4. We can use that to find a. So I substitute those values in. 7's y equals, do not know a, over 4. I can multiply both sides by 4 then, so we get 28 equals a. 28 is actually the constant variation, so then I can write the general form for all x and y's, y equals 28 over x. Now the last part of this problem is, after we write an equation that relates x and y, is to find y when x is negative 2. So then I can substitute in negative 2 for x and find that y is negative 14. So we first need to write the actual inverse variation, and then we can find our y value. So write an inverse variation model. Another example, MP3 players. The number of songs that can be stored on an MP3 player varies inversely with the average size of a song. A certain MP3 player can store 2,500 songs when the average size of a song is 4 megabytes. So like the previous problem, we're told inverse, y equals a over x. Then we can plug in what we know. We know that for 2,500 songs, we have 4 megabytes. And so we know that the songs that can be stored on an MP3 player varies inversely with the average size. The order that is written is very important. So y would be the first portion, the number of songs. And so the number of songs, 2,500 would be y, equals, a we do not know, but then we know we have 4 megabytes. So then if we multiply 2,500 times 4, we figure out we have 10,000 would be a. And a doesn't have meaning. A is just a constant variation. It's the number we use to describe the relationship between x and y. There's no meaning in that number. So our equation, y equals 10,000 divided by our x. So if you have the size of the song, you can divide 10,000 by that to figure out how many songs would actually fit on that. So here's the steps you can go through. You can write a general equation for the inverse. We can substitute in our values, and then we can actually solve for a. So how can you tell if your set of data is inverse or direct variation? Well, if you look at the equation for inverse variation, we have y equals a over x. So if we multiplied x to both sides, you'd find our a value, which is a constant. So if you multiply your x times your y's, you should get the same value. And then similarly, we have our direct variation, where we had y equals a times x. So I divide both sides by x, you'd find the same a values. If you divide x and y values, you find the same value. A joint variation. So this one's a little different. This is a joint variation where we have z equals our a value times x times y. So z is varying in relation to x times y. And so with the same process, you just have more variables. So if we know what z is, what x is, and what y is, we can substitute those in. So z is negative 75, and that equals a we do not know, but we know x is 3, and we know y is negative 5. So we have negative 75 equals negative 15a. Divide both sides by negative 15 to find what a is 5. We can rewrite our equation. Let's rewrite our equation. Z equals our a value times x times y. So that's our equation, and then as it relates to x, y, and z, then we can find z when we're given x and y. So now we can find for any x and y. So z is found by doing 5 times x, which is 2, times y, which is 6. So 5 times 6, 30. 30 times 2 would be 60. So that would be the value for z when x is 2 and y is 6. So similar to the previous problems, you first need to write our model, or find our a value to write our model, then use that model for any x and y values. So we can compare different types of variation. So if y varies inversely with x, we should know that's an inverse variation, and we should write our equation y equals a over x. If z varies jointly with x and y, with x, y, and r, so now you have the r value, you should have a times x times y times r. Jointly, it could be more than just two variables. We have x, y, and r. Y varies inversely with the square of x. So inversely with the square of x. So now you have the including the square of x. Inverse is the fraction. Z varies directly with y and the inverse of x. X varies jointly with t and r, and inversely with s. This is a little difficult. X varies jointly with t, so jointly. So, and r, so those are the two variables x varies jointly with, and inversely with s. So inversely is that fraction. So you have the joint, then you have the inverse. So you have both of them within one equation. So these can get quite complicated. So we're going to call that good for the night, and we'll see you tomorrow.